Welcome world, greeting mathematicians and fans of mathematics and all things rational. Today we're talking about solving rational equations. Technically, I'd like to point out we may have already known how to do this. And I'm going to do that with a little recall problem. And let's consider solving this equation. What if I've got x over 2 plus 3/4 equals negative 7, I don't know, tenths or something like that. So we've solved problems like this in the past, and you could perceive those fractions as being just numbers, and you could solve by saying, oh, I would subtract 3/4 from both sides, and then I would multiply both sides by 2, and you would not be wrong, but you would have trudged through the world of fractions, making life difficult for yourself, right? And I believe I discussed the concept of fraction aside before, right? The idea of fraction ocide, I think is how I'd spell it. The idea of what if we could create some sort of utopian society where we've killed all the fractions and all the world's problems and numbers are integers, right? How great would that be? And it turns out that's exactly what we do. So the key to destroying all fractions, if you were some criminal mastermind, would be finding their LCD, which then would break down at some DNA level, and it would target only the fractions and kill them, like some sort of weird sort of genetic, smart, biological bomb warfare. I don't know. So between these denominators, what would the LCD be? Yeah, 20. That sounds right. So what I'm going to do, now I'm not multiplying top and bottom by 20, and I'm not multiplying each fraction by the part of the LCD it's missing. I am multiplying each side of the equation by the LCD. All right, so multiply by 20, multiply by 20 here. Good, good, good. And behold what happens. So 20 divided by 2 is 10, times x is 10. Oh, I'm going to keep working in blue. There we go, because this is a recall problem. And you guys know that. Whenever you remember stuff, it's in blue. Yeah. 20 divided by 4 is 5, times positive 3 is plus 15. And 20 divided by 10 is 2, times negative 7 is negative 14. Right? So, behold, I've created my utopian fractionless society. Right? Because I know you guys hate fractions. I know. You evil, evil people that want to kill the fractions. I don't know why. So what would I do now to solve this, now that I live in my utopian world?
Subtract 15 from both sides?
Yeah, sure. Let's subtract 15 from both sides. And I'll get 10x equals, what's that, negative 29. And still I'm just enjoying living in my fractionless society. And then what do? Divide by 10. And oh no! Like some sort of fraction zombie back from the dead, the bomb did not permanently kill them. Life found a way, just like in Jurassic Park. And fractions have returned. But at least I had 2 whole steps in my utopian world where everything seemed safe. And the fraction only showed up at the end, so I didn't really have to deal with it that much. So that is going to be the general idea of solving rational equations. So what did I do? Step 1 was I found LCD. Oh, not found LCD of all denominators, all denoms. 2, I then mult both sides by LCD. All right, and just straight LCD, not LCD over LCD, straight LCD, right? And then solve, whichever way that would end up being. So that's the general approach, and really, we know how to do these problems. It's just, we're really just going to do a lot of example problems to familiarize ourselves with this concept. But that's the approach. We already know how to do this. We're just going to make the problems ugly now. as if with fractions they were not already, perhaps, is what you'd think. So let's say I've got the problem x plus 1 over 3x minus 6 equals 5x over 6. Oh, there's the fraction that I hate, the one I despise the most. Plus 1 over x minus 2. Yeah, so 5x sixths. Ugh. Although I like this fraction. I like that one. Actually, my favorite fraction is this fraction right here. Oh, wait. Yeah, 1/10. Yeah, that's how I'd say that. 1/10. But then that makes me want to pronounce this as 1/2. But I don't know if that works. So, in order to find the LCD of all of these denominators, the first thing I should do is actually factor them. Can I factor any of these? Which one? Yeah, what could I do with it? Yeah, yoink yoink. 3x minus 2. And I won't rewrite the whole problem just for that step. So the LCD between all of these, what do you suspect would work?
6 times x minus 2?
Yeah, 6 times x minus 2, because the x minus 2's would fit in there, 3 goes into there, 6 goes into there, perfect. And notice the step, it says multiply both sides by the LCD. Both sides, I'm referring to the sides of the equal sign. All right, so on both sides of the equation, I'm multiplying by the LCD over the LCD. This L is like a almost C, and this C is an almost L. That's weird. That's okay. So when I multiply, I like to divide first. So the LCD divided by 3x minus 2, what cancels out? The x minus 2's, and? Yeah, 6 cancels out with a 3, leaving me 2. So I'd be left with 2. There we are. I'd be left with 2 times x plus 1. You could probably distribute that out in your head, but for the sake of our notes, we'll have it written down as a nice example. When I multiply the LCD by this first fraction, let's divide first by 6, and what would cancel out? 6. So I'd be left with 5x times x minus 2. And when I multiply the LCD by this fraction, what cancels out? X minus 2, so I'd be left with 1 times 6. Right? And now notice, I've killed all the fractions. Congratulations, friends. You've committed mass fractionicide. You're terrible people. So let's distribute and solve. So 2x plus... Nope! Man, what's with me being bad at distribution today? Too much Skyrim last night, I guess. But I did join a group of vampire hunters last night, so that's pretty good. In other news. Alright, so looking at this equation, we've killed the fractions, but now what do we do? Any ideas? Eventually, I might want to do that. However, so the thing that clued her off was the squared, right? So this is a quadratic. And in order to solve a quadratic equation, I'm going to want this set equal to 0. And then if I factor or complete the square or quadratic formula, that'll be good. So the first thing we do when solving a quadratic is set it equal to 0. So let's bring these over here. And I might just give it a flipperoo as well. 5x squared minus 12x plus 4 equals 0. And now I can solve this using any of my techniques. Let's quadratic formula. I think that's what I'd prefer. Oh, well, actually no. Let's check AC method. We might as well check. Yeah. But I wouldn't mark you wrong for using quadratic. AC time, let's see, 5 times 4 is 20. Factors of 20 that add to be, let's see, 4 and 5. Which of these add to be 12? 2 and 10. Let's see, there we go, 2 and 10. So I'll split the b term into two like terms whose coefficients are the factors we just found. So, what are the signs of this going to be? Negative, negative. They had to multiply to be positive, right? Over here, this was a positive 20. So their signs were the same, yet they add to be a negative, so I can't add two positive numbers to get a negative. That wouldn't work out. And now I factor by grouping, so a yoink, a yoink. I could steal an x over here, a yoink, a yoink. I'll steal a negative 2. Always take the sign with you if you can, if your first term is negative. So I'll have x times 5x minus 2, minus 2 parentheses x, no, 5x minus 2. Man, I feel like those are the ugliest 5s I've written. Ugh. So my factors are 5x minus 2 and x minus 2 equals 0. Right? So now what do I do? What do we do? Yeah, perfect. 5x minus 2 equals 0. Let's see. Man, I'm not writing very well today. X equals 2 is one of my solutions over here. Here I'd have 5x equals 2, so x equals 2/5, which, by the way, is 0.4. So those are my answers. Now, beware, friend. It turns out, just like when we were solving radical equations a long time ago, in radical equations we had issues anytime there was a negative under a square root, right, or any sort of even root, because that would break the world. Well, at least giving us imaginary outcomes, and we didn't consider that legitimate for answers in this case. Now, in a rational equation, it turns out there are some things that we don't like. There's some math rule related to division that is never allowed. Does anyone remember which rule that might be? Things that we'd have to be aware of that could possibly give us an extraneous solution? There's one rule with division that doesn't have an answer. It cannot be done. Your calculator would give you an error if you tried dividing. Yeah, we can't divide by 0. So, it turns out that my solutions for x, I have to make sure that these denominators are never going to equal 0. And I think we have that happening. Which of our answers would give us a 0 in the denominator?
X minus 2.
Yeah, right, this guy, if I plug it in here, 2 minus 2 is 0. Uh-oh. And actually, technically, even over here, if I plug in a 2 here, this would be 0, right? 0, blah, blah, blah. So it turns out, without doing a formal check, that this is extraneous. And I would just say, denominators cannot be 0. Right? So it appears as though I only have one legitimate solution. One solution to rule them all, and that is 2/5. And if I did a formal check, it would all work out, and we'd be happy with that. So good stuff. Good stuff. Let's see, I might do one more example today. Problems are a little bit long. I think I could fit one. I'll fit it over here. Why not? Why not? I've got the real estate space to afford it. Let's see. What if I have x squared minus 1 over x plus 1 minus, well, it's an ugly minus sign. Minus, let's say I've got 2x over x squared plus 4x plus 3. Oh, that's an ugly slope. Equals, and let's say I've got, I don't know, 7 over x minus 1. Yeah, let's do this. So, looking at these denominators, I can't really find the LCD until they're all factored. So which of these, if any, can be factored? Yeah, that can just be classic factored, right? That's going to be x plus 1 times x plus 3, I believe. So what is the LCD of all of these? I think I heard it. So there's our LCD. And now what am I doing with this LCD?
Multiplying each side.
Multiplying each side by it, right? So I'm not multiplying each fraction by the part of the LCD it's missing. I'm not multiplying top and bottom by LCD. I'm multiplying both sides by the LCD. All right, right? So here we go. Blah, 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 blah. LCD. LCD. Multiply. Let's see. So, what cancels out for this first fraction?
X plus 1.
And I'd be left with x squared minus 1 times x plus 1. Nope, x minus 1, right? Times x plus 3. Yep. Let's see. I multiply by the second fraction. What cancels out?
X plus 1, x plus 3.
X plus 1 and x plus 3 would cancel out, right? So I'd be left with x minus 1 times this negative 2x. So negative 2x times x minus 1 equals, and I multiply over here, and what would happen?
That X minus 1.
Yeah, the x minus 1's cancel out, and I'd be left with 7 times x plus 1 times x plus 3. Okay. Whew. So, yeah, this is, I believe, going to be a 4th degree polynomial. Pretty stuff. I know x squared minus 1 is factorable, but it doesn't necessarily benefit us to factor it right now since I'm going to be distributing all this. So I'm going to do x squared minus 1 times, what happens when I distribute these guys? I'll get x squared plus 3x and minus 1x is a total of plus 2x. And then minus 1 times 3 is minus 3. Distribute this over here. And I will get negative 2x squared plus 2x equals, and over here, I'll distribute the parentheses first. That'd be x, oh, I already know what that is. That's this guy right here, x squared plus 4x plus 3. So, let's distribute this guy. So x squared times x squared is x to the 4th. Let's see if I can even fit all of these on one line. Plus 2x cubed minus 3x squared. All right, that was the first distribution that we did there of the first term multiplied by all of those. And now I'm doing -1 times all of these, right? So I will get minus x squared minus 2x and plus 3. And then I'd still get minus 2x squared plus 2x over here equals. And then this one's just distributing by 7. That one's not that bad. And I've got the best sound effects. Action-packed. If this was a PowerPoint, there'd be like a sound every time like text would fly in off the screen. That'd be pretty good. Plus 21. So I've got a 4th degree polynomial equation. What? I'm going to want to set this equal to 0 and solve if possible. We'll see if we can. I made up this problem. It's quite ugly. We'll see if it might not even have any real answers. So to set it equal to 0, I'm going to subtract 7x squared from both sides. I'm going to subtract 28x from both sides. And I'm going to subtract 21. I'll just put that under the 3 here to fit it. So let's see if we can combine our like terms. Let you guys catch up here. Show x to the 4th has no friends. X to the 4th. X cubed. I have no other x cubed, so x to the 4th plus 2x cubed. That's what I've got. Now I've got some x squareds. I've got -3, -1, -2, and -7. So let's see, that's -13 of them, maybe? And then I've got some other ones. Let's see, I've got -2x, positive 2x, and -28x. So these kind of cancel out, and then it's just -28x. And then I've got positive 3 and -21, which would be, I believe, -18 equals 0. And I think I might spare us the difficulty of doing this entirely. Or actually, maybe I'll show you the graph of it. I think that might be interesting. But what we could do with a 4th degree polynomial, I could find the p's and q's. I could use the Descartes rule of signs. I could synthetically divide and see which of those p's over q's would give me roots, and then I'd find depressed polynomials and keep breaking it down over and over until I found how many answers would I expect this to have at most? 4 at most because of the 4th degree polynomial. What I'm going to do for us is I'm just going to graph this real quick in Sketchpad so we can at least see what our answers might be. So let's see. So this is x to the 4th plus 2x cubed minus 13x squared. I sing a lot now that I have kids for some reason. Actually, no, I sang a lot before that, so I cannot tell a lie. So here's my graph. Let me make this a rectangular coordinate system. Man, that's pretty great. So if you look at this, it appears as though I'll have 2 real solutions and 2 imaginary. The 2 real solutions, it looks like, actually I think I can even find them. Actually, let me do this. If I click and plot this point that intersects both of those, see when they're both red, it snaps, bam. Snap, like Pokemon Snap. Let's see, here we go. And I'm going to measure the... There we go. So those are my answers. X is 3.77 and -3.81, apparently. So I might highlight this So I used technology to solve this just to save us some time, but you won't have any problems this ugly tonight. I believe all of yours at worst will be quadratic, and you'll solve them using completing the square or quadratic formula, things like that. And then comment about these. Would either of those not work in the original problem? Or more specifically, what values of x would not work in this problem? The domain's actually restricted. Maybe I'll write it in yellow. Red's a little too serious. The domain, you can actually analyze this before you even start. What can x not equal here? X cannot equal -1. Man, not equal -1. And what can x not equal here? It can't equal -1 or -3. I already knew about the -1, so it also can't equal -3. So sometimes it's worth figuring out, well, I guess kind of the domain.
Can it also not equal 1?
Oh, good catch. Thank you. I didn't even look over there. Touche. It also can't equal +1 over there. So it does have a restricted set of values, I guess. So yeah, technically it can equal -3, -1, or +1. So there's technically holes in the graph at those locations, but we can't really tell. And these values are cool. We're fine with both of those. So those are my answers. X equals 3.77. It's probably rounded. And x equals -3.81. Yeah, I don't think our P over Q method ever would have worked, actually, sadly, because I think those would likely have been irrational, so the P's over Q's wouldn't work, and yeah. Descartes could have told us about stuff, but we end up with 2 positive, 2 imaginary. Actually, looking at this, wait a minute. Yeah, 1 positive, 1 negative, sorry. 1 positive, 1 negative, 2 imaginary. So, well, anyways, I think that covers it. The big idea wasn't that end part, but the idea of you can solve these crazy-looking equations by killing the denominators, right? Multiply both sides by the LCD, ching, 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 kills them, and then it makes it just like a much nicer problem to work with. So, anyways, all right, internet friends. Wow, look at how colorful my screen is right now. I want to frame that. Put it on my fridge, maybe. Although I wouldn't frame it and put it on my fridge. I would do like one of those things. You know, it'd be weird. Put a framed picture on your fridge.